it. Okay. And guys, what I'm going to do, we're going to go ahead and start talking a little bit about probability. Okay. So guys, probability, one of the things we talk about in probability are something called likelihood or probability that if something is going to happen. So like if you're watching the news today and Tim Smith gets mad at you because you don't know where Mission and McAllen is and all that kind of stuff, but he's going to say, look guys, we got a 10% chance of rain today, right? That's what we call probability. Okay. And y'all, sometimes when we do probability type problems, it's helpful when we draw something called the tree diagram. Okay. So y'all, when we flip a coin, our coin can either land as heads or tails, right? And so when we draw a tree diagram, y'all, this is what it looks like. Either when you flip a coin, it's either heads or it's tails. Okay. And so, y'all, for this first problem here, it says we're going to draw a tree diagram for tossing a coin twice. And then you're going to use a diagram to find the number of possible outcomes. So, look, y'all, the first time we flip a coin, that coin can either land as heads or tails. Now, if we land as heads and we flip it a second time, that coin can land as either heads or tails, right? Now, if we flip it the first time, y'all, and we land on tails and we flip it a second time, it can still be either heads or tails. When we're talking about the number of outcomes, what I'm going to do, y'all, is I'm going to follow along each of the branches. That means that we can get a heads the first time, a heads the second, or a heads the first time and a tails the second, or a tails the first time and a heads the second, or a tails on both flips, right? So these are the total number of outcomes that we can get. Either a heads on both, a heads on the first, a tails on the second, a tails on the first and a heads on the second, or both of them could end up being tails, okay? Now, y'all, we're going to repeat that process for the next one. It says we're going to draw a tree diagram, but we're going to toss a coin 3 times, y'all. So look, the first time we flip our coin, y'all, can either be heads or it can be tails. The second time we flip it, it can be heads or tails. Y'all, the third time we flip it, it can either be heads or tails, okay? And then again, y'all, I'm going to follow along each of the branches and figure out the total number of outcomes. So we can have a heads on all 3, a heads, and a tails, a heads, tails, and a heads, a heads, tails, and a tails. And again, y'all, I'm just following the branches, right? Or a tails, heads, and a heads, or a tails, heads, and a tails, or a tails, tails, and a heads, or a tails, tails, and a tails. So we got 8 different possibilities here, okay? When we flipped the coin once, y'all, we had 2 possibilities. When we flipped it twice, we had 4. And we flip it 3 times, y'all, we got 8, okay? And again, these are just telling me the possibilities, what each of the number of outcomes that we could possibly get, okay? So again, y'all, one thing, I mean, tree diagrams, they can be tedious in terms of drawing them. What I like about them, they're visual. And again, y'all, I think a lot of times most of us are visual learners, and it's easy to kind of, once we draw the picture, you can kind of see, okay, look, what am I doing? He's going heads, heads, heads. He's going heads, tails, sorry. Heads, tails, heads, heads, tails, tails, right? Tails, heads, heads, tails, heads, tails, so on and so forth, right? But that's how I'm getting my possibilities, okay? So, y'all, it says if a coin is tossed twice, okay, so let me come back over here. Y'all, these were the possibilities that we had when we flipped it 2 times, okay? So I'm going to just write those down here. So we had heads, 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 tails, tails, heads, and tails, tails. Okay, so we had a total of 4 possibilities. The question is saying, find the probability that we get heads on both of them. So, y'all, out of the 4 possibilities that we have here, only one of them has heads on both. Okay. And that's why we're saying the probability is going to be 1 out of 4. Out of those 4, one of them had heads on both. Okay. All right. What about rolling a die? So y'all, remember what a die looks like? It's like a little cube, right? Looks kind of like this. And you got like a 1, 2, 3, and maybe a 1 here, and I don't know, 2 there, something like that, right? Y'all, dice have 6 sides. So we can either get a 1, 2, 3, 4, 5, or 6. Okay. So my denominator, y'all, I got 6 possibilities. Find the probability of rolling a 3 or 4. Y'all, out of those 6 numbers, 2 of them are either a 3 or a 4. With probabilities, y'all, my answers are always going to be like fraction type problems, okay? And then what we're going to do, y'all, we're just going to reduce the fractions. So 2 out of 6, y'all, is the same thing as saying 1 out of 3, okay? All right. Now, let's take a look at the next one. If a die is rolled 1 time, find the probability that the outcome is less than 4. Again, y'all, remember, 6 possibilities. I want to know how many numbers are smaller than 4. Y'all, looks like those first 3 numbers are smaller than 4. So 3 out of 6 is the same thing as a half. Okay. Okay. So guys, I'm going to scroll down to the next part here. Okay, find the probability of choosing a red marble from a box that has 1 red. So I'll tell you what, let's go like this. There's 1 red. Let's see, we can do this. Add a pen, and let's make it somewhat yellowish. Okay, 1 yellow. Okay, 2 blue, and 4 green. 1, 2, 3, 4. Okay, so y'all, here are my marbles. We got 1 red, 1 yellow, 2 blue, and 4 green. So y'all, first thing I want to do, my total. We have a total of what? 8 marbles? 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 marbles. Y'all, how many of them are red? 1 out of the 8. Okay. Now, find the probability of choosing a blue marble from the same box. Okay, out of the 8, how many of them are blue? 2 of them are blue. We can reduce that to 1/4. Okay. All right. How many are blue or green? So, y'all, again, out of the 8, it looks like 6 are either blue or green. We can divide them both by 2 3/4. Okay. And again, out of the 8, how many are red or yellow? Looks like 2 out of the 8, which again, y'all, reduces to 1/4. Okay. And this is how we find basic probabilities, y'all. Guys, one thing when you're doing, whenever you're taking your test, in the event, like the problem that we just did right now, right? In the event that they don't drop or provide you with a picture, look what that problem did for me. Drawing the picture, y'all, with 1 red, 1 yellow, 2 blue, and 4 green marbles, that helped me a lot. And guys, again, when you're taking your test, you may not have, right? They may not give you like map colors or crayons. So go like this: red, yellow, blue, blue, green, 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 green. And there's your thing, right? But again, it makes a little bit more sense because it makes it visual, a little easier to understand, okay? Okay, so let's take a look at this next one, y'all. It says, suppose that we spin that little spinner 1 time. So notice, y'all, we cut this circle into 3 equal pieces, okay? So the result of the spin is a 2. So y'all, out of the 3 equal pieces, 1 of them is a 2, okay? The result of the spin is a 3. So y'all, out of the 3 equal pieces, 1 of them is a 3, okay? Y'all, 21. Out of the 3 equal pieces, how many of them are either a 1, 2, or a 3? Well, all 3 of them are 1, 2, or 3. So 3 out of 3, y'all, is just going to give me a 1. Okay. All right. The result of the spin is not a 3. So y'all, out of the 3 equal pieces, 2 of them are not the number 3. Okay. What about an odd number? So y'all, an odd number, remember what odd numbers are? 1 and 3. So there's 2 odd numbers, right? And then an even number, y'all, would be the number 2. There's 1 even number. Okay, so 1 out of the 3. All righty. Y'all, in the next problem that I got here, it says a new drug is to be tested that's supposed to lower blood pressure. So, y'all, we gave this medicine to 200 people. Out of the 200, 152 had their blood pressure lowered. That's good. That's what we want, right? 38 ended up with a higher blood pressure. We do not want that at all, right? It made it worse. 10 people, no change. So, again, we don't want that either. The question says, what is the probability that a patient had a higher blood pressure? Okay, so remember, y'all, we had 200 people here, and 38 of them, y'all, had a higher blood pressure. Y'all, those numbers are even. We can divide them by 2. So I'll give you a hint. Half of 200, 100, okay? 38, y'all, divided by 2, 19. So 19 out of 100. That's how I would do my probability, y'all. Okay. And then the same thing for the next part, y'all. It says how many, find the probability the patient either had no change or higher. Okay. So again, y'all, 200, right? No change was 10. Higher was 38. That's 48. Okay. Look, y'all, let's divide them by 2 again. Again, 100. Half of 48, y'all, 24. Okay. Guys, we can divide them by 2 again. Half of 24, 12. Half of 100, 50. Y'all, we can divide them by 2 again. Half of 12, 6. And half of 50, 25. And that's where we'll stop because we can't reduce those anymore. Okay. All right. And then, y'all, we got another problem again, dealing with marbles, right? So this one, again, they gave me a picture. Always nice to have the picture. Let's see. Let's find how many marbles we have total. Look, y'all, 2, 4, 6, 8, 9. 9 marbles in total. Find the probability that a yellow is chosen. Y'all, out of the 9, looks like we got 2 yellows, right? So 2 out of the 9. Okay. So again, y'all, probabilities, I think for the most part, people usually tend to do pretty well with them because I think the hardest part, y'all, honestly, is like what we did here in the red, reducing the numbers, right? Notice what I'm doing, y'all. I'm cutting them in half, right? What's half of 48? 24. What's half of 24? 12. What's half of 12? 6, right? Half of 200, 100, half of 150, half of 50, 25. Why did I stop at that point? Because 25 isn't even. And the next number I would try is 3, and 3 also doesn't go into 25, right? So that's why I stopped right there. All right. Okay, so we got another couple of marble problems. So let's do these marble problems, y'all, because again, I think most people do pretty well with them. What's my total? 2, 4, 6, 8, 9. Okay, so we still got 9 marbles. How many of them are green? Okay, y'all, looks like we got 2 green, right? Okay, and the next one, how many marbles total? 2, 4, 6, 7. Okay, so we got 7 here. We're looking for either blue or green. So 1, 2, 3, 4. So y'all, 4 out of 7 are either going to be blue or green, right? Okay. All right, guys. The next part we have here is something called unit analysis. Okay. Guys, unit analysis, what this does is this is talking about conversions. And y'all, the idea here in conversions is we're trying to figure out, like there's 12 inches in a foot, there's 3 feet in a yard, there's 5,280 feet in a mile. Y'all, one thing I want to mention about the test, there should be some numbers, guys, that I think in general you should be familiar with. So like in regards to the time, I think everybody should know 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, 7 days in a week, 52 weeks in a year, 365 days in a year. Okay. In terms of the length, I think most people should know there's 12 inches in a foot, 3 feet in a yard. Some of the other ones, I mean, it's just not stuff that we use on the regular. But I think in regards to the 12 inches in a foot, 3 feet in a yard, and the time, those should be given that I think everybody should know. Okay. I don't necessarily think that everybody should know the weight stuff, maybe the 16 ounces in a pound, or that maybe the 2,000 pounds in a ton. But in either case, y'all, a lot of times for these problems, they will give you the conversion. They'll give you the 12 inches in a foot type thing. So what I'd like to do here, y'all, is figure out how do I go to each of these problems, okay? Y'all, the first thing I'm going to do here with every one of these problems, I have 27 feet, okay? So look, y'all, I'm going to write 27 feet. I'm always going to write it over 1. And I'm going to multiply it by a fraction, y'all. And I want my answer to end up in yards, okay? So guys, I'm going to scroll back over here. And I'm looking for a relationship that talks about feet to yards, okay? So look right here, y'all. 3 feet is 1 yard. Since I want to end up with yards, y'all, I'm going to put the 1 yard on the top. I'm going to put the 3 feet on the bottom, okay? Whatever unit I want to end up with is going to go here. Whatever unit I have here is going to go in the bottom part, okay? Now, y'all, I'm going to go straight across when I multiply. What I mean by that, 27 times 1, 27. 1 times 3 is 3, okay? I'm going to take my calculator. I'm going to take 27. I'm going to divide it by 3. It's going to give me a 9. Okay, I'm going to put a 9 right here. Now, what's going to happen, y'all, is that feet and that feet are going to cancel out. And these yards is what we're going to end up with. Okay. Y'all, let's do the same thing for this next one here. So look, y'all, I'm going to go like this. 27 inches. I'm going to write it over 1 times some fraction is going to be equal to my answer in feet. So what I want to do is I want to find a relationship, inches to feet. Right here, y'all. 12 inches is 1 foot, okay? I want you to notice something, y'all. We want to end up with feet, so I'm going to put 1 foot here, 12 inches there. Again, whatever units I have here, I'm going to go in the bottom. Y'all, I'm going to multiply straight across. 27 times 1, 27. 1 times 12 is 12. 27 divided by 12, 2.25. 2.25 feet. And again, those inches and those inches cancel out. We had feet here. Excuse me. And that's what we're left with. Okay. All right. Same thing for the next one, y'all. 7 gallons over 1 times some fraction is going to be equal to my answer, y'all, in quarts. Okay. Again, I'm looking for a relationship, y'all, between gallons and quarts. So let's see. Here we go, y'all. Look, 4 quarts is 1 gallon. Okay. So look, y'all, I want to end up with quarts. So I'm going to put 4 quarts right here, 1 gallon right there, right? Okay, we're going to go straight across. 7 times 4, y'all, is 28. 1 times 1 is 1. Those gallons and those gallons will cancel out. 28 divided by 1, y'all, is just 28. Okay. Y'all, I'm going to do every problem exactly the same way in regards to how I set it up. I'm looking at the units that I have and the units that I want to get to. Okay. So look, y'all, let's try this one here. First thing, 63,360 feet over 1 times some fraction is going to be equal to our answer, y'all, in miles. First thing I want to know, relationship between feet to miles. Here we go, y'all. 5,280 feet in 1 mile. I want to end up with miles, y'all. So I'm going to put 1 mile on the top, 5,280 feet on the bottom. I'm going to go straight across. Big numbers, but it's okay. That's exactly why we have our calculators. Those feet are going to cancel. 63,360 divided by 5,280, 12 miles. Boom. And there we go. Okay. All right, guys, another one I want to do here. 8 tons to pounds. Okay, so look, 8 tons over 1 times something is going to be our answer in pounds. Okay, right here, guys. 2,000 pounds. Same thing as 1 ton. Okay, we're going to go straight across. 8 times 2,000. 16,000. Over 1. Tons and tons cancel out. Y'all, 16,000 divided by 1, still 16,000. Okay. All right. And then one last one, y'all. Miles to feet. Okay, so let's do this last one. 3 miles over 1 times something is going to be our answer in feet. Okay, guys, we have the relationship right here. 5,280 feet is 1 mile. Okay, so look, y'all. 5,280 feet, 1 mile. Again, I'm going to multiply straight across. 3 times 5,280. 15,840 over 1. Y'all, my miles cancel, but when we divide it by 1, we get the same thing. 15,840. Okay. That's how we do unit analysis, y'all. That's how we do conversions, okay? Y'all, let's try the next one here. Let's see what we got here. Let's take a look. Y'all, Amy left her car in the garage for 3.5 days. Amy, don't do that. The garage charges $2.50 an hour. How much did she pay for parking? So, y'all, the issue here is that we know that she had the car there in days, right? In days, but they charge us per hour. So we need to figure out how many hours are in 3.5 days. Guys, 3.5, we can write it as 3.5. We know that there's 24 hours in a day. So we're going to take 3.5 times 24. That means that that car, y'all, was there for 84 hours, right? And then we got to take that number and multiply it by $2.50. And that means, y'all, she's going to pay, doesn't seem right. Let's see, how many hours did we have? 84 times 250, 210. So, y'all, she's going to pay $210 for parking because she left the car there in for 3.5 days, right? Okay. Y'all, let's take a look at this one. Bella bought 24 ounces of pickles, but they charge pickles by the pound. How much did she have to pay? So look, y'all, 24 ounces over 1 times something is going to be our answer in pounds. Y'all, right over here. Here we go. Let me clean this up. 16 ounces is in 1 pound, y'all. Okay. So look, 16 ounces, 1 pound. Okay. Guys, I'm going to multiply straight across. 24 over 16. 24 divided by 16 is 1.5. So look, y'all, 1.5 pounds, right? But she bought 1.5 pounds and they sell them for $2 a pound, y'all. So now we got to take that number times 2. She paid $3, right? Not too bad for a whole bunch of pickles. Okay. All righty. Y'all, we still got a couple of minutes. Let's see if we can do a little bit of the geometry because that was one of the things I want us to do today. Y'all, perimeter is just talking about the distance around a figure, okay? So let's see if we can do a little bit of this, guys, so that maybe we have a little bit less to do tomorrow. We're not playing as much catch up. Look, y'all, if this side is 2 yards, I know that side is 2 yards. And if that side is 3, that side is also 3, right? So look, let's just add them all up. So 3 plus 2 plus 3 plus 2, 10 yards, right? Okay. Y'all, same thing here. It kind of looks like a home plate, right, in baseball. So we're just going to add those numbers together. 7 plus 10 plus 8 plus another 8 plus 15. Y'all, that looks like it's 48 feet, right? And again, I'm just adding up all the pieces around, okay? Let's see. So, y'all, I want to do these next two because, again, these next two here, y'all, not as basic, right? But I can still figure them out. Y'all, in this problem here, we know from here to here is 20. We know from there to there is 28. This is 17. Guys, we need to find two things. We need to find that distance there, and we need to find that little distance over there. So let's think about it like this, y'all. If from here to here is 28, y'all, from there to there also has to be 28. Well, if that piece is 20, y'all, wouldn't that piece there have to be 8 meters? Because it has to add up to 28. And then down here on the bottom, y'all, if that whole piece there is 20, then y'all, from here to here also has to be 20. And if that's 17, wouldn't that piece right there, y'all, have to be 3? And so now we can start saying, let's add up all those distances, okay? So guys, I'm going to start here on the bottom, and I'm going to go this way, okay? So look, y'all, we got 20, we got 28, we got 17, we got 8, we got 3, and we got 20, 96 meters, y'all. And there's my picture, okay? There's my perimeter. Let's take a look, y'all. Let's try this next one over here. Same kind of idea, guys. Let's take a look. We know that this piece is 30. Y'all, I got to find this piece here. And we got to find that piece right there. Okay, let's see if we can figure this thing out, y'all. Let's see. Y'all, we already know from here to here is 13. So, y'all, from here to there has to be 13. Well, if this amount of it is 6, y'all, that piece has to be 7, right? Y'all, we know that that whole distance there is 30. So that means that from here to here has to be 30, right? Well, if that's 13, y'all, that one's got to be 17, okay? And again, let's go ahead and add them all up, right? So look, guys, again, I'm going to start here at 30, and I'm going to go all the way around. So 30 and 7 and 17 and 6 and 13 and another 13 is giving me 86, y'all. 86 inches, okay? So again, y'all, in doing these problems, you know, the pictures are really helpful because they're kind of guiding you on how you can figure out what those missing pieces are going to be, okay? Let's see. Y'all, let's do one more like this, and then we'll go ahead and try something a little bit different. Let's see. Find the perimeter of the figure. Okay, so guys, again, we're missing some pieces here, right? We obviously want to know what is this bottom piece here going to be. Look, y'all, we're going to go, look, that has to be 9 and 10 and 8. So 9 plus 10 plus 8, y'all, that's 27. So this piece here has to be 27, right? Okay. Okay. Y'all, look, if from here to here is 15, well, that's also got to be 15, right? And y'all, if from here to here is 7, then that piece there also has to be 7. Okay. And guys, I'll let you up, but again, just to give you the idea, this was our approach, right? Our approach was just to find those missing pieces, add them all up. Okay. Let's see. Let's go to the next one, guys, because again, I want to make sure that we have enough time to do, you know, what we got to do for the day. Okay, so look, y'all, it says a metal strip is being installed around a workbench that's 10 feet long and 3 feet wide. If the stripping costs $3 a foot, find the total cost of the stripping. Okay, so look, y'all, we have a bench 10 feet long and 3 feet wide. So my bench looks like this: 10, 10, 3, and 3. And we're going to put some kind of stripping around it, y'all, around the outside. That means we're looking for the perimeter. So look, y'all, 10 and 10 is 20. 3 and 3 is 6. So my perimeter, y'all, 26 feet. Okay. So we need 26 feet of this stuff, y'all, and they charge me $3 a foot. So we're going to take 26 times 3. It's going to cost us $78, y'all. Okay. All right, guys, let's do these last two problems here dealing with circumference, and then we'll call it a day, all right? And we'll pick up the rest of it mañana. Okay, so y'all, for these next two problems here, it says we were looking for the circumference of the circle. We want to find something we called an exact answer, and then something called an approximation using 3.14 for pi, excuse me. Y'all, first thing we have here, we have the formula, okay? C equals pi times d. Y'all, d is the diameter. The diameter is the distance that goes all the way through, okay? So y'all, first thing we're going to do, we're going to find the exact answer, okay? The exact answer, y'all, is going to be pi times the diameter, which is 17 centimeters. So the way we're going to write this, y'all, is 17 pi centimeters. Okay. Guys, I'm going to do the approximation in 1 second. I want you to think about the same idea that we did here. I want us to do that over here. Now remember, y'all, the diameter goes all the way through the circle. So if that piece is 8, wouldn't the whole thing have to be 16? So again, y'all, I'm going to take 8 times, or pi times 16 miles. So my exact answer, y'all, 16 pi miles. These are what we call the exact answers, okay? Now, y'all, there is something that we call an approximation. So the way we find the approximation, y'all, is we're now going to take 17 times 3.14 with the little units of centimeters, okay? So 17 times 3.14, 53.38. And y'all, when we do this, a lot of times for approximations, what we do, we go like this, 53.38 centimeters. This means approximation, okay? Same thing here, y'all. 16 times 3.14 miles. So I'm going to take 16 times 3.14, 50.24. 50.24 miles. And again, this is our approximation, okay? The exact answers, y'all, have the pi symbol. The approximations have the decimals, okay? So, y'all, we will pick up with area tomorrow, okay? I don't want to get started on area today because we've only got a couple minutes left, but we will pick up with area tomorrow. Guys, let me go ahead and do this real quick. Let me come back this way. Let me stop recording. I don't know why it's doing that, guys. It did it yesterday, but it should be recording because we saw that I hit record. But let's do this, guys. Yeah, see, somebody put in, see my recording, and we put yes. So, guys, just again, as a heads up, let me come back this way. Here on the Pearson link, y'all, come back this way. Let me let it load up. Let's see. It's taking a little bit of time. Okay, guys, if you ever click on the Pearson link, you don't have to go to home. You can just click on My Lab All Assignments. Again, y'all, the idea here, these are just practice problems, right? None of this stuff, guys, is for a grade, right? It's just to kind of help you go through the stuff. So, guys, we went up to unit analysis. We started geometry, but we haven't finished it. So we'll finish the geometry tomorrow, guys, and we'll just kind of keep working our way through, okay? But, yeah, I hope that this is helpful. Again, guys, my objective here is to help you get ready for that test and try to prepare you as much as we can, okay? So again, y'all, part of that involves, practice when you have some time. It's obviously it's going to be to your benefit, okay? So, guys, that's it for us today. I'm going to go ahead and stop the session, and then I'll upload those videos, y'all, to YouTube in a few minutes, okay? So let me go ahead and do this, y'all. Let me go ahead and leave the session, and we'll call it a day. Guys, we'll see y'all tomorrow, whether online or here in person, but I hope everybody's doing well, okay? Y'all have a good afternoon, everybody.